Welcome to this lesson on read-only properties and private methods, also known as member variables. After studying this lesson, you should be able to understand and create read-only properties and understand and create private methods, aka member variables.
So far, we've been working with public properties, and let's try and understand, wrap our heads around when we would use a private property and what does that do. So here we have, let's change this back to how it was the last time we looked at it. So we have all public properties in our developing employee class, and let's take the first one, EmpID, and change it to be a private property and see how that affects our code and what that really means. Okay, so first off, if we go look at the class diagram, notice that we see the little locky by the wrench showing you the property is now private. But more importantly, if we come over to our code, I now have an error when I try and reference that, and it says Windows app1 employee.employee ID is not accessible in the context because it is private. So why would I, if it's not usable, why would I do this? And there's a very good reason for it. It's not usable from code outside the object, but if I needed to do something in code from within the object, I could, but it's not useful here. So let's get rid of this because that's going to not even going to compile. It's just going to fail to compile because there's an error here. Let's fix that and then think up a case where having something private would make sense and why that is a really useful thing. Okay, so let's come back over to our definition here, change that back to public, and let's think critically about this design. So I'm working on my class design, and you know what I would like to know is, and there's a whole bunch of things I'd like to know I haven't gotten to, like what the pay rate is and all kinds of things. But the next thing I want to turn my attention to is how much vacation does this employee get? And let's imagine that we work for an organization that when you're a new hire, after you've been there a year, you can take 2 weeks of vacation. So from years 0 to 4, for the first 4 years, you get 2 weeks of vacation. As a longevity incentive for our loyal employees that have been there 5 years up to 9 years, let's say you get a third week. And if you stay all the way to 10 years, you must be somebody who's really a valued employee. Let's give you a month off. Let's give you 4 weeks, okay? So we need to be able to enter that, but that's not really something we want to enter directly. We want it to be automatic. Everything we have to enter means there's a possibility for error. It's another administrative task and somebody forgets to do it, and it creates problems. So if we can automate this, we can really get the benefits of all that object-oriented programming goodness to make our business run a little more smoothly. Okay, so we want it to update automatically, but we don't want people to be able to monkey with it. So we want to implement this as a business rule through logic internal or private to the class. Okay, so let's go see how would we do that. Now, I said it's private, but we really want to still be able to display how much vacation is has been earned, but we don't want you to be able to change it. So that's like half private. That would be read only. Okay, so let's see how we can implement a read only property. Okay, so back over to our code, and let's see, what shall we call this property? Let's call it vacation, right? Okay, so it's going to be a private property. No, it isn't either. It's going to be public because we still want to show it, but we're going to have a private method for changing it or creating it. What we need, though, is we need to make it read only. And it's going to be the number of weeks. Well, that would fit into an integer. Great. Okay, so we've got a public read-only property, and that also means what? It means that my constructors need to be updated to reflect that. Okay, so let's see, how are we going to set that? Well, we're going to need to implement some logic. Where can we implement logic? I know, let's make, and here's where the private part comes in. Let's make a new method, and a method is a member function. So we're essentially building a function that will be internal to this class, and that way no one can see or monkey with the logic when they're using our code library. Okay, we're using our class. Okay, so let's do it this way. Let's have a private subroutine calc vacation, and in that we'll declare service years as integer, and that's where we'll put our calculated number of years that a given employee has served. And let's see, we want to know today's date. And that's the function that will give us the current date and time. And so service years is going to be equal to the date difference, and we just want the year, whole years. So anything under a whole year doesn't count. You got to have finished out the year before you get the vacation increment. And the difference between the start date and today. Okay. Now I'm using internally that public start date thing. This is where some of that discussion of fields versus properties might start to make a little bit of sense. So if I wanted to keep it totally using private variables, only things that are internal to the class, I could come over here and refactor this and convert it to a full property, and now change this to the private variable start date. It'll work either way. So that's a nicety, but let's form good habits early. Okay, and so we're going to change the service years into the number of full years between the employee's start date and today. And then let's see, we'll do a little logic on that. Let's use a select case rather than an if then, because we got several cases to look at and we might want to expand it in future, so this will make it easy. So select the case of the service years. And what I would like to do is there's 0 to 4. And in that case, this vacation thing, and again, let's go ahead and convert vacation out to a full property for the same reason. Again, we don't have to. We could use the public property, but I'd rather use a private variable for internal calculations. And so let's say case 0 to 4 is vacation equals 2, and case 5 to 9 is vacation. Did I not get that spelled right? 2, 2, 2, 2, 2, 2. Oh, because it's read-only, it may not have, no, there it is. Private read-only underscore vacation as integer. That should be there. Copy it, make sure I've typed it correctly. Look at that in a minute. Vacation equals 3, and case 10, that's actually in all other cases. So we can just say case else, vacation equals 4, and we should be done. Let's save this and puzzle out why it's not liking that. Oh, of course, I see our problem. We said that was private by default. That one gets declared as read-only as well. So we want to make the private variable writable. Now it should be happy. Yeah. Okay. So what we need to have happen is every time a new object is created, we need to set the vacation using calc vacation. Okay. And that's going to happen automatically by setting this private variable. And we need to do that. Well, when is an object created? Anytime either of our two constructors are called, that's when that's going to be invoking that function. So let's add that function to it so that it will get called every time. So when I create a new one using the default constructor, I want to say calc vacation. And when I do it using the overloaded constructor with the parameters, I want to set it. So I never set it to a specific value. It's always set by the logic, and that's why we've made it, the property is public but read-only, and the method, this method is only ever going to be called internally by those constructors, so it doesn't have to be public. Nothing outside of the class is going to call it. And so private means that anybody in this group of friends, everything that hangs within the start of the class declaration and the end of the class declaration can use it, but nothing outside of it, like my form logic, can do that. All right, so let's take a look and see if this is now working correctly. And so let's go back and set our breakpoint, and let's do it here. No, right here, after the object is first created. And notice we don't have to therefore add any statement to change it, but we do want to go ahead and output it. So yeah, let's just say vacation weeks. All right, so let's give that a try and see how that's looking. And go. And let's take a look at first imp. And again, this one's using the default constructor. And so it's got all nothings and these defaults. Look that my fields are now showing up there because we added the fields to start date and vacation. And it's defaulted to 4. That may not be exactly what we want. But let's take a look as we step through and see what it gets set to. All right, and it's set to 4 weeks vacation, and that looks correct. So let's change this and see if instead of 1980, what it's currently 2018, and so what if I made this 2012? 6 years ago. And go and expand it out, and 4 at the default, but let's see where it goes when we come down here. Okay, so nothing is happening to change the code. What happens? Well, let's see. When it is first created, think about it. When we create the null, the default, we can call calc vacation here, but that's not really doing much for us in this case, is it? Because we don't have a start date. And so goodness knows the start date is, if it's not equal to anything, it's like, 0101 of 0001, thousands of years ago. Well, of course they get 4 weeks vacation. So this is not really where we want that. We need to update that, not only when the object is created, but anytime it is updated in a certain way. When? Anytime that the start date gets updated. So in the set routine for the start date, okay, when that happens, so anytime we set a new start date, that's where we want to call the vacation function. Now let's see what happens. So we took the calc out and we say go. And so at first when it's created, vacation is 0 because it wasn't set to anything. But we change the ID, and the first name and the last name. And here, watch when it changes the start date. It also updated the vacation to 3. So now, anytime the start date is altered, then the vacation is going to get updated as well. And now, looking at the last output, it's telling us 3 weeks. Well, that's correct. So that's what we wanted. Testing is so important. But let's think about it. Have we tested all parts of our program? I don't think so, because if we go back and look, what else can happen? Let's look at our class. So the other thing we have to test is, what about when we use that parameterized constructor to set it to a specific date? It looks like it should happen, but we really ought to test it for sure. Okay, so let's come back over here and let's create second imp as new employee. And let's use, in this case, the parameterized instructor, or constructor, I should say. Okay, so how do we call the parameterized constructor? Okay, so we want to put the parameters not here, But here, there's the overload. And notice I go to the second, it'll show me, so here is where I will put that. So let's make this the employee ID number 222. And let's make this Sarah Smith. And now we need counting the parameters over. So we have the employee ID, the F name, the L name, and the start date. And so let's put Sarah back in the 80s. 1980, except, of course, I need to convert that to a date rather than a string. So let's use convert.toDateTime. And so now as convert. Sometimes autocomplete is too helpful. And now second employee should be just what we want. So let's go ahead and add all of this also for our second employee. And let's run through it again. We'll clear this to begin with. And let's come up here. Oh, we got a break first. So let's run it to the first break. And let's add second imp there. And walk through and see F10, F10. Let's expand this out so we can see it. And second imp, bam, has changed. Oh, and look at that. With a start date back in the 80s, looks like we have 4 years. Great, that's more than 10 years, so that makes sense. And then let's go ahead and just F5 and continue the run. And we have Sarah Smith, and her information is correct. Okay, test it a second way just to make sure. I always like to do that, be real thorough. And let's take Sarah and let's make Sarah a new hire. So if she was hired on January 1st of this year, so now she should only get 2 years instead of 4 years, right? Let's run it again and go. And let me clear this out so we're not looking at old data. And let's go ahead and hit F5 and let it continue to the end. And now Sarah has 2 weeks vacation. Nice. Okay, so now we've seen a case where it makes sense to have a private method or a private member function and a read-only property. And we could even have properties, again, if it was useful to have properties. Properties are like storage variables in a lot of ways. So if we wanted to have a private storage variable of the class, we could have a property that's private instead of public. And there are also, besides public and private, there are some other settings that we won't get into. What is between private and public? Well, you might share things among friends. Well, what does that mean? We could have other programming modules in our code that are not part of the same scope that we want to treat as if they are family, treat as though they are friends. And so there are other, if we look at our class diagram and let's go ahead and stop the run. And we look at our properties and look at the class details, we can look at the modifier, pull down and see that we can have something called private, friend, protected, or a protected friend. So there are other settings. We're going to leave a study of that for another time and maybe a more advanced programming class. But there is a range between everybody can see me and nobody but I myself can see myself. We can expand that as needed for different programming tasks. All right, that's it for now. This concludes the lesson.